Hi guys, good morning. So this morning you're going to be listening to this video, and fundamentally I want you to arrive at this idea of what we call the binomial distribution. But let's just grow there. Let's get there. And it's really looking at probabilities, really, of events happening and making decisions, really. So it's about making decisions, whether to do something or not. And let's sort of see. So sometimes we need to make decisions. Sometimes making decisions are difficult because we just can't predict the unknown. So first of all, for us to even be able to make good decisions, we must need some idea of what could happen in the future. So we must have at least some figures, if you like, for the probability in question in the first place. But that's just by the way. So we tend to ask questions like, what is the probability that something will happen? What is the likelihood that a drug will work? What is the likelihood that a student will pass an exam? We could say, what is the likelihood that the student will pass an exam if the student only did the exam once, if they did it twice, or thrice, or 4 times, or 5 times? And these are all probabilities and decision-making that we will have to encounter from time to time. Probably for you guys, where I'm really trying to focus on is this issue of, because we're on a business course, if you like, is what is the probability that during an inspection that one item might be defective or 2 might be defective. So for example, if we pick 20 items, what is the probability that 1 item might be defective, or 2 or 3 or 4 or whatever? And then what do we do if we find a certain number that are defective? But you see, this question itself is very much built or follows the same pattern that we like asking, what is the probability that if we toss a coin 20 times that 1 will be a head, and 2 will be heads, and 3 will be heads, and 17 will be heads? I think I'm trying to almost set the scene very early on. That's what we're trying to achieve here. Okay, good. And so having an awareness of this probability enables you to then decide, to make a decision. What do I do? Do I take another sample? Do I check another batch? Do I stop doing this? Can I reduce the probability or change the probability? Do you see where I'm going? Now, the general thing is that all probabilities add up to 1. So, for example, if you say that what is the probability that it will rain tomorrow? Well, either it will rain or it will not rain. So if it will rain, it might be, 0.5. And if it doesn't rain, if it rains, it's 0.5. And if it doesn't rain, it might be 0.5. And that will add up to 1. I mean, if we're in the winter, if we're in in winter, if so, what's the probability that it might snow? It might be more 0.8, for example, that it will snow. And what's the probability that it will be sunny in the winter? It'll be 0.2 or something. And that still adds up to 1. So generally, all probabilities add up to 1. But typically, we will have a set number of events, if you like. And then all the probabilities of those events must add up to 1. So what do we have here? This is an example of home mortgages approved per week. So in order for probabilities to work, again, we must be adding up to 1. We can't do probabilities if the total of all the probabilities of all the events that could happen don't add up to 1. So for example, here is someone looking at a scenario and saying, well, what is the probability that we will approve no mortgages this week? Well, there's a slight probability here, 0.1, and here we have approving 1 mortgage, we have another 0.1. Approving 2 mortgages, we have 0.2. Approving 3 mortgages, we have 0.3. And you can see that we could go on where we approve 6 mortgages, 0.05. So you can see that if you add all these figures together, you will get 1. And this gives you an idea, I guess, when it comes to making a decision. We could say, and this is important, what is the probability of approving at least 2 mortgages? So if the probability of approving at least 2 mortgages kind of tells us that we are talking about at least. When it says at least, we have, it could be 6, it could be 5, it could be 4, it could be 3, it could be 2. But at least we have 2. So we have 0.5 plus 0.1 plus 0.15 plus 0.3 plus 0.2. You see where I'm going, and that's really where I'm trying to get you to. You could just have what's the probability of just 2, or at least 2, or what's the probability of having greater than 1, that sort of thing. So you can add probabilities together. Yes, you can add probabilities together to sort of know what's going on. Okay. And you can draw a graph of it, and you can find you can sort of say, well, on average, you can see that this has the highest probability, doesn't it? The probability of the probability of issuing 3 mortgages had the highest probability of 0.3. So you could say on average that we would probably be approving 3 mortgages. Yeah, and then we can also find the mean. Now, this thing about finding the mean with probability, we refer to it as the expected value. So what we do is we kind of find this kind of average thing. I mean, it doesn't really mean anything on its own because they're all probabilities. We can't say for certain that this will happen still. Right, so what we do is we sort of say, okay, then let's sort of multiply the number of mortgages times its probability, and then we sort of do 0 times 0.1, and 1 times 0.1, and we sort of do the same thing all the way down. And when you add all those expected values together, these are expected values, we get this 2.8 figure. So it's sort of taking, it's finding an average, or it's taking a weight of all the probabilities. So this is a weight of all the probabilities based on the number of mortgages, and we arrive at this 2.8. So it's telling you that the average, the official technical average number of mortgages is 2.8. Now you know you can't actually approve you can't approve 0.8 of a mortgage, but it's just what the probabilities are telling you. So I guess the question is we have to look at what's closest to this, and really it was 3, wasn't it? And we saw that anyway, didn't we? Over here we saw that we could approve, we saw that on average they could approve 3 mortgages the approval of 3 mortgages had the highest probability. And we could go on and play on Excel and work out what the variance and the standard deviation is. I'm now more interested in you understanding what the standard deviation is. And remember, the standard deviation is the deviation from the mean on both sides. So if you have an expected variance of 2.8, it's really telling you that this is the average of all the other figures from the mean up and down. So I don't know, this could be, we could do a calculation, and this could be, given that we went all the way down to, let's see, 0.1, 0.4. So you could have something interesting like maybe 0.7 both sides. Yes, maybe minus, plus, maybe even 0.8. So it just tells you that the standard deviation tells you that this is how far you are on average, the average of all your deviations, the average of everything else, all the other values from the mean. This is the average on both sides. That's your standard deviation. When we looked at that, when we looked at discrete, when we looked at when we did the earlier assignment, we calculated standard deviation and variances. Right. So that's the first video. Just to kind of give you an introduction very quickly to probability, the chance of something happening, and why we need it, right? And we will come back again, especially to this idea of making decisions based on the likelihood of things happening and whether we make those actual decisions. Okay, great stuff. See you in the next video.